This video provides a brief introduction to Cluster 4, Digital, Industry and Space, under the Horizon Europe program.
In this session, we will present a few calls from Horizon Europe's Cluster 4, Digital, Industry and Space, with corresponding destinations. The call considers turning CO2 emissions from the process industry to feedstock, as well as technologies for processing and refining of critical raw materials and advanced biomaterials for healthcare. Please note that there are several calls we do not present, and therefore a list will be provided at the end of the video. If any of these calls are more relevant to you, we will be happy to discuss these with you in a meeting. Also, if you need a higher level introduction to Horizon Europe and the terminology used, we made a separate video for that. So please see that first before continuing with this video. Progress in digital and industrial technologies shapes all sectors of the economy and society. They transform the way industry develops, create new products and services, and are central to any sustainable future. Horizon Europe's work program on digital industry and space outlines disruptions such as COVID and the war against Ukraine, when highlighting the need to strengthen the industrial base of the EU and associated countries, enhancing its resilience and flexibility both in terms of technologies and supply chains to reduce strategic dependencies on third countries. In a globalized world of heightened uncertainties and volatile geopolitical interests, what is at stake is not only Europe's prosperity and economic competitiveness, but also its ability to have access to critical raw materials, technologies, and services that are safe and secure for industry as a whole. This is not about protectionism. It's about upholding EU strategic interests and guaranteeing security of supply. The first destination under Cluster 4 considers climate-neutral, circular and digitized production. Proposals for topics under this destination should set out a credible pathway to global leadership in clean and climate-neutral industrial value chains, circular economy, and climate-neutral digital systems and infrastructures through innovative production and manufacturing processes and their digitization, new business models, sustainable by design advanced materials and technologies, enabling the switch to decarbonization in all major emitting industrial sectors, including green digital technologies. The second destination under Cluster 4 considers increased autonomy in key strategic value chains for resilient industry. Proposals for topics under this destination should set out a credible pathway to industrial leadership and increased autonomy in key strategic value chains, with security of supply in raw materials achieved through breakthrough technologies in areas of industrial alliances, dynamic industrial innovation ecosystems, and advanced solutions for substitution, resource and energy efficiency, effective use and recycling and clean primary production of raw materials, including critical raw materials and leadership in circular economy. The work program for Cluster 4 presents the following groups of calls, where we in the current video focus specifically on the first two. The first call we will present in this session belongs in the first group, Twin Green and Digital Transition, while the two others belong in the second group, Resilient Value Chains. The first call we will present considers turning CO2 emissions from the process industry to feedstock. Projects should develop efficient CO2 capture and purification technologies in combination with valorization routes towards first-of-a-kind demonstrator and de-risking investment. Projects are expected to contribute to the following outcomes. 1. Master the capture, purification, and conversion of CO or CO2 from process industry point sources and utilization of renewable energy at reasonable costs to pave the road to the production of a large range of chemicals and materials. 2. Showcase the system effectiveness of the GHG emission avoidance in the process industries, as well as the scalability and the cost efficiency of the proposed concept. 3. Enable the economic viability of the entire unit to compete with the existing state-of-the-art production of the same or equivalent products, for example, fossil-based production of chemicals and materials. 4. Prove efficient integration and use of renewable energy sources, and where relevant, account for their intermittency and the possibility to offer demand response flexibility. And 5. Increase the competitiveness and resilience of the European process industry. Proposals are expected to demonstrate the economic viability of the efficient capture and utilization of carbon monoxide or dioxide streams from point sources, for example, large and medium industrial installations such as steel, cement, refining, and chemical plants, converting the streams into added value chemicals and materials in near-to-production size systems. The proposed technologies should support cross-sectoral concepts and sector integration. The semi-industrial scale demonstrators should be at a relevant scale for economic and technical decisions for a first-of-a-kind plant. These proposed demonstrators should 1. Process significant amounts of CO or CO2 containing emissions from energy-intensive process industries. 2. Demonstrate process and cost-efficient environmentally friendly technologies for capture and fit-for-purpose purification approaches while ensuring the maximum process efficiency. 3. Demonstrate cost-efficient environmentally friendly conversion of CO or CO2 into chemicals and materials, including any relevant auxiliary required for the process, such as the formulation of reliable catalyst at the required scale, and if relevant, process-integrated downstream products. 4. Evaluate the energy efficiency of the overall CCU process and, where relevant, flexibility considerations for the efficient use of renewable energy for capture and conversion. 5. Encompass the use of advanced monitoring and control techniques and integration of advanced digital technologies which enable optimization of the overall system. And 6. Contribute to an integration effort to realize fully integrated capture and utilization systems, including optimization of materials, process interfaces, and ultimately device architectures, and to promote maximum energy efficiency. The proposals will integrate technologies to make them practically and economically viable in the process industries, optimizing CapEx and reducing CO2 abatement costs. This should be demonstrated through at least one realistic use case with a demonstrable economic return developed in close cooperation between CO2 industrial emitters, users, and technology providers. The proposals should include techno-economic analysis, and it is recommended to include GHG avoidance methodology following the guidelines from the EU Innovation Fund. And the link to these instructions can be found in the footnotes of the call. Proposals should include a strong business case and sound exploitation strategy. A project output, a more elaborated exploitation plan should be developed, including preliminary plans for scalability, commercialization, and deployment, and indicating possible funding sources. Proposals should build on or seek collaboration with existing projects and develop synergies with other initiatives, funding programs, and platforms. Where synergies are possible with projects from the topic CCU for production of fuels, cooperation activities are encouraged. The second call presented in this session considers technologies for processing and refining of critical raw materials. Projects are expected to contribute to the following outcomes. 1. Increased recovery rates of valuable raw materials, particularly from critical raw materials from low-grade or complex ores and/or from extractive waste. 2. Significantly increase economic performance in terms of higher material, water, and energy and cost efficiency and flexibility in minerals processing and metallurgical processes. 3. Significantly improve the health, safety, and environmental performance of the operations throughout the whole life cycle, including reduction in waste, wastewater, and emission generation, and a better recovery of resources from generated waste. And 4. Improve responsible supply of raw materials to Europe in line with the EU Principles for Sustainable Raw Materials. Details about the EU principles can be found in the call text. Actions should demonstrate new or improved systems integrating relevant processing and refining technologies for better recovery of raw materials from low-grade and/or complex ores, from extractive wastes, less waste, higher energy efficiency. The actions could also reduce the content of toxic elements or compounds in the resulting material productions and should target minerals and metals, particularly critical raw materials. The solutions proposed should be flexible enough to adapt to different or variable primary and secondary raw material grades and should be supported by efficient and robust process control. Where relevant, any solution proposed for the reduction of content of toxic elements or compounds in the resulting materials should also include the appropriate management of the hazardous substances removed. Actions should develop intelligent and innovative production systems which better utilize natural resources by minimizing losses during waste rock separation in an optimized and energy-efficient process and by minimizing use of water. Proposals should include a business case and exploitation strategy. For TRLs 6 to 7, a credible strategy to achieve a future full-scale deployment in the EU is expected, indicating the commitments from the industrial partners after the end of the project. Analysis of financial opportunities should be included, ensuring the market exploitation and replication of the circular business model behind the developed solutions as new processes, products, and/or services. Clustering activities with other relevant selected projects should be included, and proposals should foresee a dedicated work package or task for this. More details about the expectations for these activities can be found in the call text. Actions should facilitate the market uptake of solutions developed through industrially and user-driven multidisciplinary consortia covering the relevant value chain and should consider standardization aspects when relevant. While integration of the gender dimension is not a mandatory requirement, if it's relevant for your specific proposal, you're strongly encouraged to include it. Note that recycling of end-of-life products is excluded from this topic, though joint processing of waste streams originating from the end-of-life products recycling could be included and has to be duly justified. The last call presented in this session considers advanced biomaterial for healthcare. This topic refers to the innovation market for healthcare and medicine. Several materials specifications and related innovation needs will support this topic, such as renewable and recyclable materials, alternative active ingredients, design for circularity, and lightweight materials. Projects are expected to contribute to 1. Develop the swiftly growing innovation market of medical applications, which is dependent on advanced biocompatible materials that can be printed or injected, including 4D materials that change their 3D structures following external impact, such as thermic, electric, mechanical, or radiation treatment. 2. Medical and/or surgical procedures will benefit from injectable materials for non-invasive surgical procedures. And 3. Some of their advantages include easy deliverability into the body, increased implantation precision, controllable release of therapeutic agents, antimicrobial properties, and the possibility of monitoring or stimulating biological events. Proposals should address at least 4 of the following activities. To enable a fast development of new advanced novel injectable biomaterials, digital tools such as modeling, simulation, and characterization techniques, including those provided by analytical infrastructures, assisted by advanced methods such as physics-based methods, machine learning, or artificial intelligence. The innovation market of medical applications is fast-growing and dependent on advanced biocompatible materials that can be printed or injected. The 4D materials will change their 3D structures after external impact, as mentioned. Proposals shall demonstrate new engineering strategies that present functional characteristics beyond biocompatibility and express properties that can be used to control the physiological environment, shape memory self-healing properties, and induce a response. Proposals shall address biomaterials with antibacterial properties, contributing to the widespread bottleneck of antimicrobial resistance often encountered in clinical care. Demonstrate the scaling of injectable hydrogels, including those made of nanocomposite, natural and synthetic polymer-based biomaterials, bone cements, bioceramics, and electronics. The design for circularity has to develop, when relevant, biodegradable or bioabsorbable materials that are gradually eliminated by the body after fulfilling a purpose. The biomaterials used should be safe and sustainable by design, taking also into account any specific medical requirements. Proposals submitted under this topic should include a business case and exploitation strategy. The topic requires effective contribution of social sciences and humanities and involvement of experts, institutions, and relevant expertise within SSH. Early involvement of end users could be essential. Projects should build on or seek collaboration with existing projects and develop synergies with other initiatives, funding programs, and platforms. Where relevant, proposals should seek links with and capitalize on the results of past and ongoing EU-funded research projects, including the ones under the Health Cluster and the Cluster for Food, Bioeconomy, Natural Resources, Agriculture, and Environment. In this list, you will find the other calls under Twin, Green, and Digital Transition, all for the deadline February 7th, 2024. And Resilient Value Chains, with 4 calls to the same deadline, and 2 two-stage calls with Stage 1 deadline at the same date, and Stage 2 deadline September 24th, 2024. If you would like to discuss an innovation action and the potential fit for your company, we will be happy to set up a meeting. Please send us an email, either to me or any of my colleagues.